This video is on how to find missing sides or angles in 45, 45, 90 triangles and 30, 60, 90 triangles. This is standard 1.1. Alright, so let's start with our 45, 45, 90 triangles. And one thing that you have to know is the ratios of the sides in these triangles. So let's take a 45, 45, 90. If I mark the sides congruent, we automatically know it's a 45, 45, 90 because our angles here have to be congruent as well. And since all angles in a triangle add up to 180 degrees, these two angles would have to be 45. All right, so the ratios of the sides in a 45, 45, 90 triangle are x, x, and x root 2. And using these ratios, you can then find the missing sides in any 45, 45, 90 triangle. So let's take a look at our first example. Suppose we have a 45, 45, 90. And you are given that one side here is 12. Okay? And you want to find the other two sides. So what you want to do is think about which side that 12 corresponds to. And it corresponds to the x right there. So then we can write the equation 12 equals x. And there really isn't anything to solve for. X is isolated. So now we replace x with 12 on the other two sides. So if we take a look at the other leg of our triangle, which is represented by x, we can replace that x with 12. And if we look at the hypotenuse, which is x root 2, we can replace that x with 12 as well and get 12 root 2. Okay? That example, pretty straightforward. Let's take a look at another one. So let's again take a 45, 45, 90. And this time I'll mark the sides congruent. And like I said earlier, that automatically sets us up as a 45, 45, 90 triangle. And this time, suppose we're given the hypotenuse is 5 root 2. Okay. Again, you want to figure out which side of our triangle that corresponds to. Well, the legs are x, and the hypotenuse is x root 2. And so you're going to set the hypotenuse equal to x root 2. And then you want to solve for x. So our equation is 5 root 2 equals x root 2. And to solve for x, we want to divide both sides by root 2, undoing the multiplication by which it's attached to the x. Dividing the left side, we are left with 5, and dividing the right side, we're left with x. So x is equal to 5. Now we can replace the x's in our original triangle with 5. So that means this leg is 5, and that also means the other leg is 5. So the two legs of our triangle are 5. Okay? Let's take a look at a third example. So in our third example, again, let's take a 45, 45, 90. And let's say the hypotenuse is this time 5. Right? Even though there isn't a root 2 attached to it, it's still the x root 2 side because it's the hypotenuse. And so now our equation looks like the following. 5 equals x root 2. To solve for x, we're still going to divide both sides by root 2. And on the right side, the root 2 is canceled out, so we're left with x. But on the left side, we have 5 over root 2. You can leave your answer like this, but it's not considered simplified because you have a root in the denominator. So let's take our 5 over root 2. And to simplify, we're going to use this process called rationalization. So we're going to multiply the numerator by root 2 and the denominator by root 2. And when you do that, the new numerator is 5 root 2. And the denominator, root 2 times root 2, is just plain old 2. And you can leave your answer like that, or because 5 and 2 are compatible, they both exist outside of your root, you can do the division and leave it as 2.5 root 2. And notice what we've done is we've solved for x. X equals 2.5 root 2. So now going back to our original triangle, let's replace both x sides with 2.5 root 2. So that's one leg of the triangle. and that's the other leg of our triangle. Notice this time the x sides have the root 2 attached to it, and the hypotenuse doesn't have a root 2 attached to it, and that is okay. These red x, x, and x root 2 represent the ratios between the sides, not what the side actually should look like, if that makes sense. Okay. All right, let's take a look at 30, 60, 90 triangles. All right, so now we are looking at 30, 60, 90 triangles, which is our other type of special right triangle. Okay, and let's start with our basic 30, 60, 90. And remember, this could be turned anyway, so you really have to look at where the angles are, rather than just what's at the top or the bottom or the sides. And the ratios of a 30, 60, 90 are the following. Across from the 30 is the x, across from the 60 is the x root 3, and across from the hypotenuse is the 2x side. And again, you're going to look at the triangle that you're given and think about what sides you have to figure out the other two. Okay? And so let's take a 30, 60, 90, and let's start out with the example of this side being 12. Okay? First, think about what side you're given. Well, 12 is across from the 30, and across from the 30 is the x side. So we're going to set 12 equal to x. Okay? Now, the other two sides are easy to find in this particular case because we've already solved for x. There's nothing really that we need to do to isolate the x here. Since the hypotenuse is 2 times x, we can replace the x with 12. So the hypotenuse is 24. And since the side across from the 60 is our x root 3 side, we could replace the x with 12. And that leg is 12 root 3. That's probably our easiest case of a 30, 60, 90. Okay. Let's look at another example. Suppose that we again have a 30, 60, 90. Let's put the 60 here this time. And let's say that we're given the hypotenuse, and the hypotenuse is 14. Okay. Again, think about what side you're given. So 14 is the hypotenuse, which is the 2x side. And then that's the equation that you're going to have to set up and solve. 14 equals 2x. Dividing both sides by 2, we can see that x equals 7. So now we're going to find the other sides. Across from the 30 is x, and we can replace that x with 7. And across from the 60 is x root 3, and if we replace that x with 7, 7 root 3 is our other leg. Okay? Let's look at another example. Let's see if I can get a new page in here. This is my very first video, so I'm just trying to figure out how things work. That was example number 2. Okay, let's look at example number 3. So example number 3, I'm not sure what's happening there. Let's take our triangle. I'm not sure why things are disappearing. We'll just go along with it. All right, so now let's say across from the 60, we're given that side to be 8 root 3. Again, think about what side you're given. Across from the 60 is the x root 3 side. So we're going to write the equation x root 3 equals 8 root 3. And that's the equation that we're going to solve. Well, we can take our equation and divide both sides by root 3. And the root 3's are going to cancel out, so you're left with x equals 8. Okay? And so x here across from 30 is now equal to 8. So this side of our triangle is 8. And the hypotenuse, which is the 2x side, is 2 times 8. So the hypotenuse is 16. Okay? One more example of a 30, 60, 90. And this is probably the trickiest example. And again, I don't know why things are disappearing on us here, but we're just going to go with it. So let's take our 30, 60, 90. And this time across from the 60, let's suppose that is a 9. Okay. And again, I don't want you to get thrown off by the fact that there's no root 3 attached to it, even though it's across the 60-degree side. That is perfectly fine. So 9 is the x root 3 side because it is across from the 60. And so the equation that we have to set up is 9 equals x root 3. Okay. And to solve for x, we're going to divide both sides by root 3. And the root 3's will cancel on one side, but you have 9 root 3 left on the other. And like the 45, 45, 90, you could keep the root in the denominator, but it's not considered simplified, so we can rationalize by multiplying the numerator and denominator by root 3. And you're left with 9 root 3 over 3. And the 9 and the 3 are compatible because they're both outside your root sign, so you can divide and get 3 root 3. And that's our x. So now going back to our triangle, replace every x with 3 root 3. This x, which is across from the 30, is 3 root 3. Okay. And the hypotenuse is 2x, so it's 2 times 3 root 3. And so it's 6 root 3. And again, don't be thrown off because the sides that are across from the 30 and the hypotenuse have root 3's attached to them, and then the side across from the 60 doesn't. That's perfectly fine. Again, these x, 2x, and x root 3 are ratios of sides, not what you should see on the actual number.